So today what we're going to be working on is solving second degree trig equations. So I'd like you to do the try this, put me on pause, and then come back and check your answers. Okay, so let's take a look at number 1. It says solve for x. So I have x squared minus 9 is equal to 0. So that's a quadratic equation. It's a second degree equation. So I'm going to factor. It is the difference of two perfect squares. I get x plus 3 and x minus 3. We make a t-chart. We get x is equal to negative 3 and x is equal to positive 3. All right, let's take a look at 2. We have x squared minus x minus 6 equals 0. So you can solve this. You can use quadratic formula. You can factor. If it's factorable, complete the square. All right, so I'm going to factor. I'm going to multiply the first times the last, do master product. So I get negative 6x squared. What multiplies to 6 minuses to a 1, that would be 3 and 2. 3x and 2x. They get different signs. The larger number gets the middle sign, so it's negative 3x and positive 2x. And put the minus 6 at the end and x squared at the front, and then we'll factor by grouping. So the GCF of the first group is x, and then we get x minus 3. And the GCF of the second group is positive 2 times x minus 3. So my factors are x plus 2 times x minus 3. And then set them equal to 0, we get x is equal to negative 2 and x is equal to positive 3. So basically when you solve a second degree trig equation, it's almost the same thing. We are going to be solving quadratic types of equations and then going back and making them trig equations. All right, so let's take a look at what we're supposed to do. So your first thing you're going to do is you're going to make a substitution. You're going to let x equal your trig function. You're going to solve the quadratic function. You're going to use either factoring, quadratic formula, complete the square. You're going to replace the x with the trig function, so you have to do your substitution back in. You're going to find the angle by using the inverse key. You're going to find all the angles in the interval. Now, if they're just angles around the unit circle, not on the axes, there should be 4 angles unless there isn't an angle. Okay, so you'll know when there isn't an angle because you'll get an error. And then we'll talk about why that actually happens when it comes up. Or if it's a special angle. Special angles are angles that fall on the axes, like 90, 180, 270, 360, 0. All right, so let's take a look at the first one. We have solve for theta. So we have tan squared theta minus 3 tan theta minus 4 is equal to 0. And I want my angles in the interval from 0 degrees is less than or equal to theta is less than 360. So I'm going to start by writing a let statement. Let x equal tan theta. So I'm going to rewrite this. So this will be x squared minus 3x minus 4 is equal to 0. Okay, so I'm going to factor this. This is factorable. Not all of them are going to be factorable. Okay, but this is factorable. So I multiply the first times the last. I get negative 4x squared. What multiplies to 4 minuses to 3 would be 4x and 1x. So that's positive 1x and negative 4. Bring down the front. Bring down the end. And now we're going to factor by grouping. So the GCF of the first group is x times x minus 4, and the GCF of the second group is positive 1 times x minus 4. So my factors are x plus 1 and x minus 4 equals 0. T-chart, we get x is equal to negative 1 and x is equal to positive 4. So now I have to replace my x with tangent. So it's tan theta is equal to negative 1. And tan theta is equal to 4. Okay, so we're going to do the inverse of tan, right? So second tan, type in negative 1. So theta comes out to be negative 45 degrees. All right, so let's draw a picture. Negative 45 degree terminates in quadrant 4. I need my angle to be in between 0 and 360. Tan here is negative. It's negative 1. Tan is negative in quadrant 4, so that means I want this angle. So that's 360 minus 45. So 360 minus 45 is 315. And tangent is also negative in quadrant 2, so that means I want this angle. So I need this angle here, which is my reference angle. That's 45. So the red angle will be 180 minus 45. And 180 minus 45 would be 135. And make sure you cross off that negative 45. All right, on to the other side. So we do second tan, 4, and theta comes out to be 76. Okay, so let's draw a picture. 76 degrees is in quadrant 1. Let's see what quadrants we need to be in. So tan is positive, positive 4. Tan is positive in quadrant 1 and quadrant 3. So I need the angle that terminates in quadrant 3 now, this angle. So to get that angle, I need this angle here, which is the reference angle, 76. So to get the red angle, it would be 180 plus 76. So 180 plus 76 would be 256, and that would be my other angle. So I have 4 angles here. Okay, so let's take a look at number 2. All right, so I have sine theta minus 1 equals 0, and my angles I want to find in the interval from 0 to 2 pi. Okay, so I'm going to start by writing a let statement. So let x equal sine theta. So I have x squared minus 1 equals 0. So I can factor this. This is the difference of two perfect squares. So it's x plus 1, x minus 1 equals 0. So I get x is equal to negative 1, and x is equal to 1. So I'm going to replace x with sine. So it's sine theta equals negative 1, and sine theta equals 1. All right, so I do second sine, type in negative 1, and we get negative 90 degrees. Okay, so that's a special angle. Now, besides that it's negative, it is special because it does fall on the axes. All right, when an angle falls on the axis, this is what I'm saying when you get special angles, angles that fall on the axis. Draw the unit circle. So on the unit circle, label the points. So this point to the right would be 1, 0. The point up here would be 0, 1. Point to the left would be negative 1, 0, and then 0, negative 1. Okay, so I have negative 90 would be this angle. So that's not my interval, so I need this angle. So that would be 270. So cross that off. Theta equals 270. And we'll change that to radians in a minute. So let's work on this side. So we do second sine 1. Second sine 1, and I get 90 degrees. So you have to check. So remember, sine is your y value. I'm looking for where my y value is 1. My y value is 1 only here at 90 degrees, right? My y value is 1. It's 0 here, and it's negative 1 here. So it's only at 90 degrees. All right, so 90 degrees would be pi over 2. 270 degrees would be 3 pi over 2. Okay, so let's take a look at number 3. Okay, so number 3 is solve for theta from 0 to 360 degrees. So I have sine squared theta minus sine theta equals 0. So I'm going to start by let x equal sine theta. So I have x squared minus x equals 0. So the GCF is x, so it's x times x minus 1 equals 0. So I get t-chart, I get x is equal to 0, x is equal to positive 1. All right, replace x with sine. So I have sine theta equals 0, and sine theta is equal to 1. All right, so we're going to do second sine, 0, and we get theta is equal to 0. So that's 0 degrees. All right, so that's a special angle. It's on the unit circle. All right, so this point here is 1, 0, 0, 1. Negative 1, 0, and this point here is 0, negative 1. So I'm looking for where my sine value, my sine is equal to 0. Remember, sine is y. I'm looking for where my y value is 0. So my y value is 0 here at 0 degrees. 90, no. 180, yes. So theta equals 180 degrees. 270, no. Around to 360, yes. At 360, but you can't put 360 because it's not in my interval because I don't have that equal sign underneath. So you have to erase that one. So then I have just 0 and 180 degrees. All right, so do second sine, 1, and theta comes out to be 90 degrees. And I'm looking for where my y value now is equal to 1, and that's only at 90 degrees. Right, my y value is 1 here, not here, not here, and not here. So those are my answers. It's 0, 90, and 180 degrees. Okay, so that's it, and we'll practice in class tomorrow. Have a good night.